Welcome again. In this video, we're going to look at the other type of variation, and we call that the inverse variation. Just as we did when we did direct variation in my last video, that we say x varies directly as y, or x is directly proportional to y, or we say x is proportional to y. The same way we have what we call the inverse variation. I'm going to use a real life application as a case study. Now, if two persons want to travel from Lekki to the airport, and driver A is driving at 100 km/h to the airport. Driver B is driving at 120 km/h to the airport. They will take the same road to the airport. Who gets to the airport first? Will it be the person driving at 100 km/h or the person driving at 120 km/h? Kindly pause the video to think about that. All right, you will all agree with me that the person driving at 120 km/h would definitely get to the airport first. Why? Because the person is driving at a faster speed. So the meaning is this: the higher the speed, the less the time it takes to get to the airport. So if you increase your speed, you get to the airport faster. If you reduce your speed, it takes you more time to get to the airport. And can I say something? For those of you that are economics students, you would have learned what we call the law of demand, that the higher the quantity demanded, the higher the price, the lower the quantity demanded, and the lower the price, the higher the quantity demanded. So indirectly, the two laws of demand you learned in economics is the same as inverse variation. Okay, good. So how do we write things like this? Then let's check it out. If we say x varies inversely as y, because it is inverse, we have 1 over this. Because it is inverse, don't forget, multiplicative inverse of 2 is 1 over 2. So multiplicative inverse of y will be 1 over y. Therefore, I would have x to now be equal to k times 1 over y, which means x is equal to k over y. And this becomes the formula, where you have your k to still be what we know as the constant of proportionality. Good. Now, I'll show you how the graph of an inverse variation looks like. This is the graph. Because the higher this here, the lower it comes here. Yeah, good. Oh, somebody said, but it should go a straight line. Why is it curving here? Don't forget that it can't touch 0, because if you substitute your y to be 0, 1 over 0 is undefined. So that's the reason why that curve is going that way. Good. Let's take some few questions, maybe about 3 in this case, and you will appreciate what it is to do inverse variation. Very simple topic. Okay. Sorry. Oh my God. Okay, so let's take the first question on inverse. It says the light intensity E is inversely proportional to the square of the distance r. Don't forget the word square. E is oh, No, sorry. You can see this is the mistake many students will make. Inversely, so that tells you that it is very important to take notes, or else you're likely going to make some mistakes. So let's bring in our constant. So that means E gives us K over R squared. So let's start the interpretation. E is 4 when R is 50. So that's E is 4 equals K over 50 squared. So we cross multiply and K equals 4 times 50 squared, which means that K is equal to 4 times 2,500 and K equals 10,000. So the first question says we should express E in terms of R. So E is equal to 10,000 over R squared. This is what they mean. As I told you in my previous video on direct, as soon as you bring in the constant, it becomes your relationship or the formula. Then B says that we should find the value of E when R is 20. So that means we'll have E equals 10,000 over R squared, which means we'll have 10,000 over 20 squared. And that gives us 10,000. 20 squared gives us 400. 0, 0, 0, 0. And that makes our E to be 25. And lastly, they want us to find the value of R when E is 1,600. So still using the same relationship, E is 1,600 equals 10,000 over R squared. So we cross multiply and we have 1,600 R squared is equal to 10,000. So over 1,006 over 1,600. So this cancels out this. R squared gives you 0 cancels out 0, 0 cancels out 0. So we have 100 over 16. To get your R, you take the square root of 100 over 16. And what's the square root of 100? 10. Square root of 16, 4. And that makes your R to be 2.5. And this is how you run inverse variation problem. So you can see it's just inverse of another. Direct, just a linear. Inverse, you have a fraction. And that's it. I hope you enjoy it, and I hope you now have a better understanding of inverse variation as well. Now, there are many questions you can practice on these IGCSE kind of questions, which will help you to understand this topic better. Thank you for watching the video, and I hope this helps.